I'm Kerryn Hart. In this presentation, I'll be exploring the reality of incomplete knowledge associated with decision-making in complex systems. I'll be looking at how scenario analysis can be used to support decision-making in my case study of managing travelling stock reserves, or TSRs, in the Western region of New South Wales. What are complex systems? Landscapes with people are complex systems. They are non-random, spatially differentiated, temporally evolving, heterogeneous, non-linear entities. Complex systems also include social, political, and economic factors. While we may think an ecosystem is untouched by humans, many have evolved with human intervention, for example, Aboriginal fire regimes. Dependent on their state of modification and regenerative capacity, specific ecosystems may require intervention for biodiversity and ecological functioning. Conventional intervention approaches are generally single objectives in simple environments. This managerialism approach is a heavy output-focused, one-size-fits-all, bureaucratic, product-focused method. We know the environment is not suited to this type of management due to complex, wicked problems. Characteristics of wicked problems in environmental management are definition difficulty, multiple causal factors, unsuitability of the one-size-fits-all approach, social complexity with divergent experts and stakeholder values on nature, scope, and solution. The wicked approach is an adaptive whole system management approach combining distributed decision-making, diverse opinions and creativity, pattern-based predictions and predictive management, trade-off-based objectives, and sharing failures. The reality of decision-making for environmental management is that we don't have nearly enough information to make informed decisions for the best possible ecological outcomes. Data allows quantitative decision-making. One way to overcome this incomplete knowledge is to use active adaptive management and apply predictive scenario-based analysis. Scenario analysis involves assessing, proposing, testing, and evaluating hypotheses. Using the wicked approach of predictive management in the form of scenario analysis can support decision-making in complex systems. Scenarios use different potential interventions to understand which actions trigger which responses. Scenario analysis helps address the uncertainty of imperfect knowledge in complex systems and provides a direction for management. It is an if-then process that involves developing scenarios, comparing scenario results, and evaluating their consequences. Scenario analysis shows how ecosystem functions might develop over time and gives an idea of the potential implications of different interventions. By testing planned interventions, scenario analysis allows land managers to choose the best possible actions with the available information. Data collection and biodiversity inventory is required for quality information, so scenario analysis can be applied effectively. If we know the state of an ecosystem and how modified it is, we can apply more appropriate interventions. Possible scenarios can be tested and ranked using multi-criteria analysis, including conservation values, stakeholder attitudes, and cost-benefit analysis. This allows the preferred scenario to be determined according to desired objectives. Elements of scenario analysis are initial situation, which is the starting point, driving forces, which are determinants influencing change, time steps, which are stepwise system changes, alternative images, which are alternative futures, and the final one, the time horizon, which is the desired future. Travelling stock reserves, or TSRs, are a network of Crown land parcels originally used for droving stock between markets. TSRs in the Western region of New South Wales are managed for economic, environmental and cultural outcomes. This makes TSRs complex socio-ecological systems and suitable for scenario analysis. Conservation assessments of Western Region TSRs were conducted in 2018 using the rapid assessment method to determine conservation value ratings for each TSR. This rating is a baseline for comparison against future assessments and is also a tool for scenario analysis in current management. This assessment is a three-part scoring system to broadly categorise each TSR. It uses conservation status, landscape context and vegetation condition and habitat, which results in a conservation value rating. This rating is used as the initial situation to inform scenario analysis for intervention prioritisation. Stepwise changes resulting from assumptions on how driving forces unfold and interact can be analysed. For example, how different grazing regimes or tree planting might affect different conservation value TSRs. The desired future of a TSR can be chosen and presented as a narrative description for strategic planning. More detailed data, including flora and fauna surveys, will be collected on individual TSRs in the future to allow improved scenario analysis. Management will be adapted to maintain and/or improve conservation values on each TSR, with prioritisation given to high conservation value TSRs. In summary, incomplete knowledge in decision making for complex systems means scenario analysis can be used to support decision making. Scenario analysis can indicate what different interventions might trigger what responses. This gives us a better chance of managing for the best possible future outcome.